We know that the reactive site of an alkene is the double bond, and a very typical reaction that alkenes undergo is known as an addition reaction. In an addition reaction, we have a molecule that has an X part and a Y part that adds across the double bond. And the two carbons that were originally double bonded to one another at the end of the reaction are then singly bonded to the X part of the molecule and the Y part of the molecule. So one carbon bonds to the X part and one carbon bonds to the Y part. And then the carbons that were originally involved in that double bond or trigonal planar are now tetrahedral and have only single bonds. So a type of addition reaction that actually we see in our everyday life is hydrogenation. And when hydrogenation occurs, we have the formation of trans fats. So hydrogenation occurs when we take a mono or polyunsaturated fatty acid, which are naturally occurring. And on the slide, we have a mono unsaturated acid, cis-palmitoleic acid. And cis is always the naturally occurring formation of that double bond in fatty acids. When we add hydrogen, an H2 molecule, across that double bond in the presence of a catalyst, we get an alkane. However, this reaction usually does not go to completion, and some of the alkane will revert back to an alkene. But when it reverts back to an alkene, it goes in the trans isomer, which is actually more energetically favorable. And this trans fat has shown indications that it is not that good for our body, that our body can't digest it well, and it seems to cause all sorts of problems. So you've probably heard of trans fat, and trans fat is formed from the hydrogenation or the addition of hydrogen to unsaturated fatty acids, and then this trans fat, forms as part of that process.